All right, we are looking at lesson 50 today, geometric mean. Yes, I remembered to record it by myself. All right, the altitude is drawn to the hypotenuse of a right triangle. Then the two triangles formed are similar to each other and to the original triangle. So, do you see how well, it doesn't have it on there, but this is one right triangle, the big one. Do you see the two smaller triangles that are both right triangles? Anytime there is this picture, all three triangles are similar to each other. Like that's part of that figure. So you don't have to show that they're, unless it says show that they are similar. You don't have to prove that they're similar unless it says to prove it. If it says find these two, you know that they are all three similar to each other. Does that make sense? Okay, so what we want to do is find RS and PS. Do what? Any ideas how you could find RS and PS? Okay, what proportion would you use? .6, okay. That's what Gabby says. 9 is the hypotenuse, and 12 is the hypotenuse, so those should both be on top. Is this the shorter leg of this triangle? The Y? Yeah, it is. Is the 9.6 the shorter leg of this triangle? No. So we wouldn't want to put 9.6 here, we'd want to put X there. So that doesn't help us. So it's got both variables in it. Any other ideas? Okay, how could you use Pythagorean theorem? Does that make sense? What do you get for X? Did anybody use proportions and get 7.2 for X? Yeah. Okay, the proportions that you could use would be 9.6 over X equals shorter leg is that. Actually, let me think. Longer leg. She'll come back and get it. Huh? Okay. If she doesn't come back to get it, although I bet she will. Hypotenuse and hypotenuse, and then longer leg is that. And longer leg is that. Like that. You'll end up getting the same thing. Did you have that except Y instead of X? Yeah. Does that make sense? Okay, so now we have X. How could we find Y? Nine over Y equals what? 12 over what? Oh, you're saying just plug X in there. Okay, yeah, that'll work. Just take this and plug in X. Does that make sense? What do you get for Y? Do y'all see how that works? Yeah. Any questions here? Hopefully she won't come back while you're on your way down there. Any questions on this one? Okay. See if you can find GD and GC by yourself. Sometimes you can use Pythagorean theorem on these. A lot of times they make it so that you can't use Pythagorean theorem. Okay? So if you can use Pythagorean theorem, go for it, but most of the time you're not going to be able to. What would you do? But all right, 10 is the hypotenuse, right? And X is the hypotenuse, right? 6 is the smaller side. Does 8 look like it's the smaller side? So, what do you get? 13 1/3, 13.3, 13.3 repeating. Depending on how it asks for your answer would depend on how you would write it. If it didn't specify any of those. Any questions to find in that side? Okay. What about GC? Do what? What would you do? What would you do? Yep. Does it make sense? And what do you get for y? Right? No, 10. 10.6 repeating. Go ahead. I just made it up. Oh, no. Well, okay, the whole FG is 16.6. So, you win. Any questions there? Okay. All right, geometric mean for two positive numbers, a and b, the geometric mean is x. And you plug it into this formula, a over x equals x over b. All right, so find the geometric mean of 4 and 16. Any ideas what the geometric mean would be? Anybody else get 8? What are our A and our B? It doesn't matter which one's your A and which one's your B. Does that make sense? And so x squared would equal what? And so what would x equal? You see how that works? Any questions there? Okay. No. It says the geometric mean can only be applied to positive real numbers, and geometrically speaking, the geometric mean is the length of the square whose area is equal to that of a rectangle with dimensions a and b. So yeah, it could be plus or minus 8, but since it's the length of a square, then it has to be a positive. I knew that was in there somewhere. What would be the geometric mean of 5 and 11? 7.4. Do I need to go over that? And say 5 over x equals x over 11. X squared equals square root of 55. So x equals whatever the square root of 55 is, 7.4. Yeah, you could. All right. Corollary. Corollaries deal with theorems. This corollary deals with theorem 50-1. That's where the 50-1 comes from. And it is the first corollary that deals with that theorem. Corollary 50-1-1. Does that make sense? So that's where the random numbers come from. It's dealing with the first theorem in this lesson. And it's the first corollary about that theorem. The name or the corollary? To what? Hyper. I don't know. There was a word that I shortened in my math, like whenever I would write notes, I would shorten them in college because they would go so fast. So I'd be like writing really fast and they didn't slow down. And there was a word that I shortened, and then like when I went back to my notes, I was like, I don't know what that word is. Alright, so I'll draw you a picture. I would include this in your notes just so that you understand what the corollary is saying. So there are 3 right triangles. If you have that picture, the length of the altitude is the geometric mean between the segments of the hypotenuse. Does that make sense? Do you see how that works? Okay. And then this is the other corollary. It says to remind students that corollaries are derived from theorems and may be seen as a convenience. Like, basically, it's breaking down the theorem for you and telling you some hints about the theorem. you can refer back to the main theorem instead of the corollaries, like in a proof or something. You wouldn't have to refer to a corollary. You could just say theorem 51. When you do what? He had some pretty, like, if you read some of the stuff he writes, or like in the books, I don't know that he actually writes all of it, but if you read some of it, it's kind of funny. I think it was the Algebra 2 book. It talks about quality of threeness. Not Algebra 2, Algebra 1 book. It talks about quality of threeness. Yeah. Here are 3 pencils. They have the quality of threeness. Here are 3 whatever. It has the quality of threeness. Like, it was really random. Alright, so a leg. So you pick a leg. Oh wait, not a leg. X for a leg. It is a geometric mean between the hypotenuse and the segment of the hypotenuse that is closest to that leg. Does that make sense? B is closer to X than this one is. Like, you're looking at this one versus this one. Or if you had, well, are any of y'all red and green colorblind? No? Okay, well, I was about to write in green and then like do different colors, but if you can't see the difference between red and green, then it wouldn't help you much. So if I use this one, the whole thing is still A, and this becomes my other value that I would use. Does that make sense?
Wait, is that a B or 6?
You're talking about the whole big triangle, yeah.
Is that B or 6?
A B. So the B depends on which leg you're looking at of the big triangle. I would learn those two. They're going to be used a lot. It'll make these very quick. Okay? You don't have to, but I would. So let's look at an example. Does he do this in other classes? Okay. No, if it's a big class, I imagine Brian just sitting there and like not saying anything. So just sitting there and not saying anything. Any ideas what you would do on this one? Wait, okay. Wait. Okay, Brian, what would you do? Does that make sense? Because the hypotenuse, the altitude that is drawn in, the x, is the geometric mean of the 2 parts of the hypotenuse. So what would you get for x? Y'all see how that works? Any questions here? I will say, you may be thinking, where am I going to use geometric mean in real life? Like, these are only with triangles. My husband came home Monday and was like, he's about to start his master's, and he was getting ready, like studying some stuff for it, and he was talking about So I was looking at geometric mean, and I was like, really? And he was like, yeah. And I was like, well, what is yours? Is it just a over x equals x over b? And he's like, no, it's the cube root of this times this times this. If you're, anyway, it's dealing with finances. But, okay. Right? Right? But in finance, it was like, I don't remember what it was dealing with, but it was like over more than just 2 years. So like if you're looking at some kind of rate of return, something like rate of return, well, you don't just want to look at it for 2 years. You want to look at it for like 3, 4, 5, 6, 10 years or whatever. So 1, 2, 3, 4, 5, 6. If you're looking at 6 years, you take the sixth root of it. Does that make sense? So that's still geometric mean. It's just looking at more than just 2 items. So anyway, it does have applications. I thought it was interesting.
Wait, so you add up how much money
You would multiply them.
like when you multiply them
Yeah, and then take the sixth root for the 6 years. And I don't know. No. I don't know. I don't remember how it applied to the finance part. I just remember that he was talking about geometric mean. And it just so happened that we were doing that lesson this week. So he could explain how it worked, but I can't. I just know there is an application to it. You're complaining about my handwriting?
Your C looks exactly like your E.
Your A looks like your B, and your B looks like your C, and your C looks like your D sometimes.
It's like your A and your B and your whole alphabet kind of looks kind of like stupid.
And then your numbers all look like letters sometimes. I put your test at the end then to grade. I grade it last. So that I don't have to have anybody else deal with the frustration after I grade his test.
Yeah, Miss Brooks just said type it out. Like she had I would prefer to like
And she had so weird.
Yeah, but like for math, yeah.
you take letters and then bring up the calculator. There's like
Yeah.
a lot of stuff you can do.
I don't know. Any ideas how to find C and D? What would you use? Yeah? The second corollary? Which says does that make sense? The whole hypotenuse and the short hypotenuse next to that leg. So D equals what? Does that make sense? Okay. Looking for C, what would you do? Yeah, use 12 instead of 9. And so what would you get for C? 13.4. Any questions on those two? Y'all see how that works? You can prove it if you want. Not really.